Hi, this is Jacek at Optitech again. We are continuing our quest to find out the exact nature of focus issues we have with our lens on the camera. In previous videos we determined that the camera back focus was okay. We checked it with our optimator, and then we put a lens on it, and we found that the lens was off. Now, a couple of notes. Lenses, usually if we talk about still camera lenses, usually they are set by the manufacturers to be a little short. The reason being, this way the infinity is always guaranteed. If there is a dirt between the lens and the camera flange, if the lens, usually when they loosen up they go long, so even if the lens wears out a bit, the infinity is always guaranteed. This is fine for autofocus still cameras, but it's not preferred for motion picture. Motion picture, the focus is continually changed while the image is being recorded, and if it's bad, then the picture is not going to look good with manual focusing lenses. We do need our focus, our back focus on the lens to be precise and correct and exact. There is several ways to do it, to check the back focus on the lens. One of the ways is a traditional collimator. This is what a collimator looks like. This is a type of collimator called auto collimator, and because it's a vertical auto collimator. The way this works is there is a light source right here, and then there is a semi-transparent target that is right in this area. The placement of the target is very precisely related to where this objective is, and then the image is projected from this objective and through this lens. So let me just put this lens on. I think it's a little bit. Through the lens and bounces off a mirror that's on the bottom here. The position of that mirror is determined by this little scale here. So that tells us the back focus error. And then it bounces back and goes back through the lens, and it bounces off a prism, and we can see it in this little eyepiece right here. This is why it's called auto collimator. The image actually goes through the lens twice. And if there is an error where the sharp image forms in the distance from this seating surface here to the mirror, then that error is doubled because the lens goes through the image goes through so it's easier to see. Anyway, this is just a short explanation how the image is tested, traditionally how the lenses are checked. We are not going to do that today. We have a different way of doing it that we came up with. It's more suitable for digital cameras. What we came up with here is a very direct and simple to understand way of testing back focus on the lens. Basically, we are using an off-the-shelf E-mount camera. We added a little wireless receiver to it, so we don't have to have trip over cords when we testing. And the reason we have an E-mount camera is because we can put an adapter on it that we want, and we are going to test an EF mount lens, our lens that was off in the previous videos. So we need an EF to E-mount adapter, and we have one here, except that this is a special adapter designed and built purposely for testing back focus on lenses. It features a very unique mechanism that changes, it's basically adjustable thickness of that adapter or adjustable height, so that we can change the back focus. We can change the flange depth of the camera effectively. Also, it is the way when we change it, we can read the amount of change in this little scale basically we change it by rotating this ring with a lever, and then there is a little scale that shows us how far off or how far we changed it. There is a 0 and then numbers from 1 to 6 going each direction. I put a little tape on here to help us with determination whether the lens is short or long, plus and minus. Basically that's very simple. So next we're going to be, and of course in order for us to see it easier, to just be very transparent and very legible, we will send this high definition image from this little camera onto a monitor. So in order to see our image and be able to easily see the focus changes, we need a monitor, and it's just the way it works the best. So we here at Optitec offer this field test kit with a standalone wireless receiver with a high definition monitor built in, battery pack inside, so it could be used without any cord. The idea was to just make it simple and don't tangle into cables and cords, and no need for external power. Yet being able to just take it anywhere and be able to test the camera and the lens. So there's space in this case for our camera with the test adapter. There's an optimator in here, and of course a screen, a high resolution screen, battery pack. So next we are going to point the lens at the chart and show how to find out how far off our lens is and which direction, and then we'll be talking about actually making the adjustment. So now let's get to it. Same technique, we are pointing the lens wide open at a chart at relatively close focusing distance to minimize the depth of field and maximize our precision. And we're going to start from 0, which is the perfect back focus for the lens, and then use the same technique. We're going to go to the telephoto position, and we are going to, let me just punch in the nice thing about these new cameras is that you can punch into a pixel level, so you can actually have, no matter how high resolution the camera is, you can see what the camera sees. So every pixel, if it's sharp on the screen, that means it's going to be as sharp as possible on the on the camera. So what we're doing here, as you can see, I'm barely moving the focus ring at the telephoto position, and we can see a drastic change of focus. So let me just get it where I think it's right, or so. And now we are still punched in, so now we're going to zoom it all the way wide and do the same thing, refocus again, but this time we're not going to touch the focusing ring, which is our front focus, which is for testing purposes only used at the telephoto position on the zoom. And then we are going to actually effectively move the lens in relation to the sensor by changing the thickness of our adapter. So it's at 0 now, that means it's perfect back focus. And let me punch in a little bit more. Still punched in. So let me just zoom it. Okay, and now I'm going to zoom it in so we can see the image better. Let me punch in now. Okay, so now we have the image as big as possible. We're looking at the image at the pixel level, and I'm going to move our back focus and find out where the sharpest focus is. Sometimes you just need to look at the moire, and then where there is the most color, that's where your image peaks with sharpness, and it seems to be around here for me. Okay, so, and there we are. We can still, just to see if our front focus is still correct, we should probably just zoom it back in, and we magnifying image even more with the zoom and the punch-in, and as you can see, I'm barely moving the focusing ring, and the image is just going completely soft. So it's kind of nice because we can see the change of focus very easily. Okay, so it's probably close to the same place. And then I'm gonna move back and do our back focus again. Okay, so I think here. All right, yeah, so our scale, our little scale tells us that we are indeed to the minus, meaning that the image is sharp in front of the sensor when it was 0, and it is by 3,000ths of an inch, or between 2 and 3,000 of an inch. So now we can take the lens out, take it to the workbench, and replace the shims, and see if we can remove 2,000ths of a shim, and that should put the image right where we need it to be. We'll put it back on the camera and test it again. Thank you. In conclusion, we just finished checking our lens back focus. We found out it was indeed long, between 2 and 3,000. Needs the adjustment. Next, we're going to be putting it on the bench and taking it apart and fixing it. We used our camera as a baseline because we determined this is how we test cameras here at Optitec. We determined that it was correct, the lens was off, and if you find this video helpful, please subscribe to our channel. We'll be continuing with these educational videos. This is Jacek at Optitec. Thank you.